All right, so we just did some exploring with the side angle side congruence, looking at rigid motions that will map one to the other. So that can lead us to an actual congruence theorem, the side angle side congruence theorem. It says if two sides and the included angle, that's why it's SAS, the order of that is very important, of one triangle are congruent to two sides and the included angle of another triangle, then we can conclude that the two triangles are congruent. So let's put a visual with that. Let's say we have triangle ABC, and here we have triangle XYZ. So we would have to know in some way that we have AB congruent to XY, BC congruent to YZ. So there's the two sides congruent. The included angle would have to be angle B is congruent to angle Y. So if we knew all those congruencies to be true, then we can conclude that triangle ABC is congruent to triangle XYZ. All right, the next thing that leads us to is CPCTC. This came up in our learning target and vocab video. If two triangles are congruent, so once you have used a congruence theorem to say that, oh, I have enough congruencies to state that the triangles are congruent, that means that each pair of corresponding sides is congruent and each pair of corresponding angles is congruent, or are congruent, is congruent. That sounds a little weird. So what that means is all the corresponding sides, so side AB is congruent to side XY. Now that was already given to us. Side BC, and I'm using the triangles above, is congruent to side YZ. We knew that. But because the triangles are congruent, because of CPCTC, we can say that AC is congruent to XZ. Now angles, we already knew that angle B was congruent to angle Y. That was given to us. But all the other corresponding angles are congruent as well. So that means that angle A is congruent to angle X, and angle C is congruent to angle Z. Corresponding parts of congruent triangles, so you have to have congruent triangles first, all the corresponding parts are congruent. Corresponding parts of congruent triangles are congruent. All right, so now let's see how we might apply all that great knowledge we have in our brains now. We've got Allie. Allie cuts two triangles from a rectangular piece of metal along the dashed line to make earrings. How can Allie show that the earrings are the same size and shape? So you can see we were told it's rectangular, so there are some properties of rectangles we get to apply. And she is cutting them in half basically along the dashed line right here to give her two triangles that ultimately, if those are two triangles that are going to become a pair of earrings, you do want them to be the same shape and size. So how can we show this? Let's start by redrawing the two separate earrings that she has created by cutting that. She's got two triangles she's working with. So here's one of them. We have A, B, D, and this is that line she cut across right there. The other triangle, I'm just going to write over here, it's going to be B, C, D. Okay, so because the sheet was a rectangle before she cut it, we know that there are right angles. So angle A is a right angle and angle C is a right angle. That just came from our rectangle right here. A and C are right angles, so we're going to make them right angles in our separate triangles. Because they're both right angles, that means they're congruent. They are congruent. So angle A is congruent to angle C. All right, another thing we know about rectangles is that opposite sides are congruent. So if we look back to our rectangle, AB is going to be congruent to CD. So let's go ahead and mark that in the picture. AB is congruent to CD. And I'm just kind of listing over here congruencies we're coming up with. How do we know that they are congruent? Because that's one of the properties of a rectangle. We didn't just mark it congruent because it looked congruent. We know that opposite sides of a rectangle are congruent. All right, well, we have other sides of the rectangle. We have side AD and side BC. So here's AD, that will be congruent to BC. So what we have right now are 3 congruencies marked in each triangle. We have 2 sides and an included angle that's congruent to 2 sides and the included angle over there. So we can conclude by side angle side, triangle ABD is congruent to. Now we want to be careful that we go in the same order. Because I started with angle A, I have to start with its congruent angle over here, which would be C. So it's congruent to triangle C. And then I went from A to B. I followed along that side that has just the one congruency mark. So if I'm at C, I have to follow along the side that has the one congruency mark. So I'm going to use vertex D next. So C, D, and then our last one is B. So because the triangles are congruent, we can use CPCTC to conclude that all corresponding parts will be congruent. Therefore, her earrings are the same size and shape. So nice job, Allie.